In this video, I will do a few examples of factoring. The examples get harder as we go. They start with our a, or our coefficient of x squared, as 1 and get more difficult. Factoring is one of the most useful skills in Algebra 2. You will use it all the time to solve quadratic equations, and the best way to get really good at factoring is to get really good at multiplying and just to practice it. So in this first example, I see that the a, again, is 1. So I'm going to break this into two binomials. And you may have noticed the pattern that this term here comes from multiplying these terms. So since there is an x squared there, I know that I will just have x times x. And then this 20 comes from multiplying these together. So I know that I need two numbers that multiply to 20. So it could be 1 and 20, could be 2 and 10, could be 4 and 5. Since I know that I have a minus here, I know that I'm actually going to have two negatives that will multiply to positive 20, but then add to negative 9. And so if I want them to add to negative 9, I will do negative 4 and negative 5. I can check this by multiplying. So x times x is x squared. X times negative 5 is minus 5x. Negative 4 times x is negative 4x, and then we have a positive 20. So these together are what adds up to give us that middle term of the negative 9 here. Since the coefficient was 1, this is one that I kind of was just in my head doing trial and error of numbers that add to negative 9 and multiply to 20. The next example here says solve, so I'm going to do that by factoring. We see that since we have a quadratic term and a linear term, we couldn't just subtract and take the square root or something like that. And so the first thing I'm going to do is actually factor out the greatest common factor here, which is 3. So I know that 3 times x squared gives me 3x squared. Then I would factor out a 3 again, so minus x and minus 6, still equal to 0. And now I need to factor this trinomial into two binomials. And since the coefficient here is a 1, I again am looking for two numbers that add to the negative 1 that we see here and multiply to the negative 6. So I can break that down, and I again will fill in. So that would be x minus 3 and x plus 2. And I know that because if I were to multiply that over to the side, x minus 3, x plus 2, this gives me x squared plus 2x minus 3x, and then minus 6 here. And so I do get back to my original trinomial. And since it says solve, and we have an equation and it equals 0, we can set each of these factors equal to 0. So 3 can't equal 0, but x minus 3 equals 0 when x equals 3. And x plus 2 equals 0 when x equals negative 2. So that is my solution here, versus number 1 just said to factor. Oops. So my answer was actually this factored expression here, which is a skill that we are learning and practicing in order to be able to solve, in order to be able to find our x-intercepts, right? This would be if y were 0. The next two examples are just factoring. In these cases, there is no greatest common factor, so I cannot help myself by doing that. And so I end up doing trial and error. And so the reason why these are a little bit trickier is that a is not 1. And so we have a bunch of different things that we will need to try. So some people like to actually sort of like write out the different combinations. So for example, we know that in order to get the 2x squared, we're going to need a 2x and an x. But then in order to get the negative 5 right here, we don't know if it's going to be negative 5 and 1, or negative 1 and 5, or positive 5 and negative 1, or positive 1 and negative 5. And so some people actually like try out all of these. And so in all these cases, we have our 2x squared and we have our negative 5, but we need to figure out what combination is going to give us this correct middle term of negative 9, right? So for example, in that first one that I wrote out, I would have negative 5x and I'd have a positive 2x. So I know that that one does not work. I could actually write these out here if I wanted. Some people like to actually write out all of these. It is important to keep your list really organized as you go. And I will show you how I would instead do this with mental math in a second. So then we try the next set. And so again, we already know that we have the 2x squared and the negative 5, but we want to see if this combination, this negative x and this positive 10 is correct, which it is. So this is our final answer. So this first one we had eliminated. And so one way to do this would be to write out all the combinations. So 2x minus 1 and x plus 5. We should, of course, check it. 2x squared plus 10x minus 1x minus 5. So we know that we're correct. You always want to multiply back out. If I were personally doing this, the way that I would do this is I would list out my factors of 2, so 2 times 1, and my factors of 5, 5 times 1. Now, I know that we are going to end up with a positive and a negative, so I'm trying to figure out what combination of these two and these two will subtract in order to give me that 9. So when I eventually find, oh, if I have a 10 and a 1, I can subtract. That tells me, okay, well, I know I have the 2x and the 1x, and that comes from this 2 and this 1. And then I say, okay, well, I want my 2 to be paired with my 5. So I'll put the 5 paired here and my 1 paired here. And I know that I want my positive term to be the 10x instead of the 1x. So I used mental math here. Since 2 and 5 are prime numbers, there weren't as many factors, but in the next example, we'll see where that would get to be a lot more useful than writing out all of our combinations. So the final example, and of course, feel free to pause this at any time and try this on your own. But we have a lot of different options here because we don't have a greatest common factor, but we also don't know if this is going to end up giving us an 8x and an x, or if we're going to end up with a 4x and a 2x in order for us to get the 8x squared term. And then for the 15, we don't know if we're going to have 15 and 1, and we know one of them is positive, one of them is negative. So like, you know, positive 15 with negative 1, or negative 15 with positive 1, or positive 5 with negative 3, or negative 3 with negative 5, positive 5, sorry. And then we could have all those same things again down here, right? So we could write these out and write out all of the different combinations here and cross them off as we go. That would be one strategy. We'd hope we'd get lucky. Or over to the side, we could list out our factors of 8. So it could be 4 with 2, or it could be 8 with 1. And then 15 could be 15 with 1, or it could be 5 with 3. And again, I unfortunately see this minus here, which means that I'm going to end up subtracting to get 14. And then I need to figure out which set is bigger. So I'm kind of going through with mental math, and I'm saying, okay, 4 with 15 and 2 with 1. When I multiply 4 with 15 and 2 with 1, I cannot subtract to get 14. That's going to be way too big. So what if I go the other way? What if I go 4 with 1 and 2 with 15? Well, 4 and 30, that won't work. So I know that that can't work. And then I'll try the 4 and 2 with the 5 and the 3. So 4 times 5 gives me 20. Does 20 minus 6 equal 14? Okay, well, that is promising. So, so far, I never ended up trying the 8 and the 1, and I never ended up trying the 8 with the 1. So I think it's going to be this, right? 4 with the 5 and 2 with the 3. So let's think about how we'd place those in here. So we'd have a 4x and a 2x. Then we say, okay, well, what is paired with the 4? The 5 is paired with the 4. The 3 is paired with the 2. I know that I want a positive 14, so I know that my sum is going to have to be 14, so I want my positive to be the product 20. So I'm going to try what I just did. So I would have 8x squared from 4x times 2x plus 20x minus 6x minus 15. So that's 8x squared plus 14x minus 15. So I did have the correct answer here. This is my answer. I will write it up here. So 4x minus 3 and 2x plus 5 are the two binomial factors that allow me to factor this trinomial here. So again, I could do a lot of mental math, figuring out what pairs together. Different people have different strategies here with the amount that they write out in this list. Some actually like write all the different combinations with the signs. I do not. I do a lot more mental math. Or you could write out each of these different combinations here. So good luck, try some, try to work backwards from the keys, and ask for help if you need it. And one thing here I should have shown is that all of these also could be the other way. We actually have 16 different combinations that we're trying, and that is why it is helpful for us to use more mental math here.